Hello guys and welcome back to my YouTube channel or the Vig Structural Hub, and this is the number one channel for structural insight and a place where you learn, build and innovate. So today I want to introduce you to the structural Eurocode, and this will be all about the design of structural elements using Eurocodes. Remember, we have different codes based on different states. For example, we have the BS 8110. So the BS 8110, it belongs to Britain. We have so many others, the Indian standard, the American standard, and so on. So today I want to introduce you to the structural Eurocodes, and then from there we will do examples concerning the structural design of elements using Eurocodes. So in this, there's a lot of theories uh, in the introduction. So I will be skipping some of these theories. So I want just to give you what is relevant uh, to our study so that we may not waste a lot of time. So if I begin, so the structural Eurocode uh, includes the following. So if you can see where my cursor is, these are the structural Eurocodes. So we have the EN 1990. So this is the Eurocode for basis of design. And then we have EN 1991. This is Eurocode 1. This is for action on structures. And then we have EN 1992. This is the Eurocode 2, design of concrete structures. And then EN 1993. This is the Eurocode 3, design of steel structures. And then we have EN 1994, Eurocode 4, design of composite steel and concrete structures. And then we have EN 1995, Eurocode 5, design of timber structures. EN 1996, Eurocode 6, design of masonry structures. EN 1997, Eurocode 7, geotechnical design. EN 1998, Eurocode 8, design of structures for earthquake resistance. And then we have EN 1999. This is the Eurocode 9, design of aluminium structures. So I will go ahead and give you the benefits of these Eurocodes. So the benefits of the Eurocodes, number one, we have the construction product will help lower trade barriers. So I have just make a short notes from this from here. So number one, as I have said, construction product will help lower trade barriers. So that is benefit number one or advantage number one. So it is here. Just check where my cursor is. So the first and foremost reason is that the provision of Eurocode and the associated European standards for construction product will help lower trade barriers between the member states. So that is benefit number one. Benefit number two, it will boost international standing of engineers, which should help in increasing their chances of winning work abroad. I think this one is again from here. And then we have number three. This is benefit number three. It encourages international competition and lower cost. So it will encourage or it encourages uh, international standings. It encourages international standings or competition and lower cost. So it is here. see where my cursor is, it is further believed that their existence will boost the international standings of European engineers, which should help in increasing their chances of winning work abroad. We have another benefit. It says that it encourages international competition and lower cost. I think I've said that. So it is easier cross-border approval of construction product. So easier cross-border approval of construction products. That is another benefit. So we have the benefit problem associated with drafting the Eurocode. I think I will not talk about that one. We have the production of Eurocode. Again, I'll not talk about that one. We have terminologies previously noted. Loads are now called action. So if you check in the BS 8110, you realize that for BS 8110, it uses loads. And in this code, instead of loads, they use what we call action, while dead and live loads are referred to as permanent and variable action. So for the BS 8110, so they use the term dead load or a live load, while in this code, they use permanent and variable action, respectively. So that is the difference. Similarly, bending moments and axial loads are now called internal moments. So bending moment in this code is called internal moments, and axial loads is called internal forces. So let's move on. We have principles and application rules. So in order to produce documents which are A, concise, and B, describe the overall aim of design, and C, provide specific guidance to how this aim can be achieved in practice. The material in the Eurocode is divided into principles and action rules. So principle, it comprises general statements. For example, definition, requirements, and model for which no alternative is permitted. And then the principles are indicated by letter P. So principles are indicated by letter P after the clause number. The application rules are generally recognized rules which follow the statement and satisfy the requirement given in the principles. So this can be seen in figure 7.2. The absence of the letter P after clause number indicates an application rule. So that is it. We have national determined parameters and national annex. So I will talk about that one. So we have minimum reinforcement areas. So number one, if if cracks control is required, a minimum amount of bonded reinforcement is required to control cracking in areas where tension is expected. The amount may be estimated from equilibrium between the tensile force in concrete just before cracking and the tensile force in reinforcement at yielding or at lower stress if necessary to limit crack width. So this is the formula for calculation of area minimum. We'll learn that later. So we have other things. Annex, we have the decimal points, as you can see. We have non-contradictory complementary information. Non-contradictory complementary information. So to assist designers to use Eurocode, the system allows the national annex to refer to sources of non-contradictory complementary information, NCCI. An example of NCCI relevant to concrete design is published document PD 6687. It was prepared and published by BSI and include the following. So I won't talk about that. So we have the decimal point. So in the Eurocode, the decimal point has been replaced by a comma. So the decimal point that uh, is used in BS 8110 is now replaced by a comma. So as well, to make it consistent with other codes, you can still use the decimal points. You can still use the decimal points. So we have implementation, we have the maintenance, we have difference between national standards and Eurocodes. So the difference between national standards and codes, I have them here in my book. So Eurocodes are internationally harmonized, modern limit design rules used across many countries, while national standards are country specific, vary widely and use local design rules and material specification. So we'll proceed to Eurocode 2. So we'll start the design of reinforced concrete using Eurocode 2 or EN 1992. So this chapter describes the content of part 1.1 of Eurocode. So in the Eurocode 2, let's begin with introduction. So Eurocode 2 applies to the design of building and civil engineering works in concrete. It is based in limit state design. So it is based in limit state design. And as you know, the limit state design is divided into two design. So we have the ultimate limit state and the serviceability states. So, and this principle comes in four parts as shown in table 8.1. So we have general rules and rules for buildings. That is part 1.1. Part 1.2, structural fire design. And 2, we have reinforced and pre-stressed concrete bridges. And then the last one, part 3, liquid retaining and containment structures. Design of building structures cannot wholly be undertaken using part 1.1 of Eurocode 2. However, reference will have to be made to a number of other documents, notably EN 1990 and Eurocode 1, to determine design values of action. This is section 8.5. So BS 4449 for mechanical properties is one of the reference. We have section 8.4.1, part 1.2 of Eurocode 2 for the fire, BS 8500 and EN 206 for durability design, and Eurocode 7 for foundation design. So the main reason cited for structuring the information in this way is to avoid repetition and make design guidance in part 1.1 more concise than BS 8110. The following subjects are covered in Eurocode 2. So we have section 1, we have the general, section 2, basic of design, section 3, materials, section 4, durability and cover to reinforcement, section 5, we have structural analysis, section 6, we have the ultimate limit state, section 7, serviceability limit state, we have section 8, detailing reinforcement and pre-stressing tendons, so this is general. We have section 9, detailing of members and particular rules. Section 10, Addition rules for precast concrete elements and structures. Section 11, lightweight aggregate concrete structures. And then the last one, section 12, plain and light reinforced concrete structures. Also included are 10 annexes, which provide supplementary information on a range of topics including creep and shrinkage, reinforcing steel, durability, design, and analysis of flat slabs and shear walls. So we have here the supporting documents. So these are the supporting documents for Eurocode 2, part 1.1. So you cannot just use only this document for this document, which is Eurocode 2. You need other supporting documents like BS 4449, Eurocode 7, BS 8500, like so on, like so on. So we have the structure of Eurocode 2. I will proceed to symbols. These are the symbols which are used in these codes, Eurocode 2. So the following symbols which have largely been taken from EC2 have been used in this chapter. So you have number one, geometric properties. So you have B, width of section, D, effective depth of the tension reinforcement, H, overall depth of section, X is the depth to neutral axis. We have Z, lever arm, up to D2, effective depth to compression reinforcement. We have bending. We have GK, which is characteristics permanent action. We have QK, characteristic variable action. So in the other book, in the other codes, which is PS 8110, so the characteristic permanent load is the dead load. No, the characteristic permanent action in the BS 8110 is the dead load. We have the characteristic variable action. So in the other code is live load or imposed load. We have the characteristic wind load, which remains the same in this code and the other code. We have the lever arm, characteristic compressive cylinder, strength of concrete at 28 days. We have the characteristic yield strength of reinforcement, FCD. This is the design compressive strength of concrete. You have the design yield strength of reinforcement. You have the design action up to the partial factor for materials. So this is the symbol for the partial factor for materials property. And then we have the coefficient taking account of sustained compression. So here it is. Then we proceed to shear. So this one is for shear. K is a coefficient relating to a section depth. S is the spacing of stirrups. Z is 0.9 D. So for the other code, it is 0.95 D. Angle of shear reinforcement to longitudinal axis. This is the symbol is this one. So those are the symbols for shear. And then you have the compression. So for the compression, you have the width of cross section, which is B. H is the depth of cross section. This one is for the clear height between ends restraint, effective lengths, relative flexibilities of rotational restraints at column ends. This is the limiting slenderness ratio for ignoring second order effect. We have again, this is a continuation. This is a continuation for compression. It's a continuation for compression. And then you have the material properties. We have concrete, and like BS 110, the design rules in Eurocode 2 are based on the characteristics 5% compressive cylinder strength of concrete at 28 days, which is FCK. Equivalent cube strengths are included in Eurocode 2, but they are only regarded as alternative method to prove compliance. Generally, the cylinder strength is approximately 0.8 times cube strength of concrete. So FCK is equal to 0.8 times FCK cube. So we have the reinforcement steel. According to Annex C, the design rules in Eurocode 2 are applicable to steel reinforcement which characteristics yield strength in the range 400 to 600 Newton per millimeter square. Detail of the action yield strength of steel available in the UK for the reinforcement of concrete can be found in BS 449-2005. This document indicates that steel reinforcement will now be manufactured in three grades, all of 500 Newton per millimeter square characteristics yield strength, but with different durability. So this is in table 8.3, plain bar of characteristic yield strengths. We have concrete strength classes property. This is table 8.2. This is based on table 3.1 of Eurocode 2. So this is the concrete strength. And then you have the tensile and other properties of steel for reinforcement of concrete. Here it is. This is table 8.3. You have table 8.4, partial safety factor for materials. So let's now talk about the design strengths. So the design strengths, this is clause 2.4.2.4 of Eurocode 2. Generally, the design strengths XD are obtained by dividing the characteristic strengths by the appropriate partial safety factor of materials. So this is it. The characteristic strengths by appropriate partial safety factor. So the partial safety factor for concrete and steel reinforcement for persistent and transient design station are known in table 8.4. Note that Eurocode 2, the partial safety factor for ultimate limit state has a value of 1.5. This is different to BS 110, where the partial safety factor is a function of the stress type under consideration. So this is the partial factor for materials based in table 2.1. This is Eurocode 2. Limit state, you have the ultimate. This is for concrete 1.5, and for reinforcement and the pre-stressing steel 1.15, and then serviceability 1.0, and then 1.0. I end there for today, and in my next session, I will begin from action. I'll talk about action, characteristic action, and so on and so on. I will handle this, the theories this way, and then we'll begin a serious calculation after this. So in our designing, we'll be tackling examples from this book, and then even borrowing examples from BS 110 as we compare the design process between the Eurocode 2 and BS 110. So thank you for your time, and let's meet in my next session.